Welcome to Intro to Linear Equations in One Variable. What we're going to do in this video is go through some fundamental problems and develop a strategy for how to solve linear equations in one variable. And what this is going to do for us is help us expand this strategy that we have with one variable to 2 to 3 and so forth until linear equations all boil down to this nice fundamental example. So all of them start off usually with the directions solve. Sometimes they're nice and they give us more than just solve. Usually what solve implies to us is whatever variable that is we're working with, okay? Generally the variable that we are working with is x. So our first one that we have is x plus 5 equals 15. And what I usually do when I'm faced with equations is the first thing I do is kind of guess what could be my answer. And this is a mental guess. I don't do any work on my paper. I just stare at the problem and kind of go, what do I think I could plug in for x that would make this statement, this equation, true? And go ahead, think of something right now. Don't be writing anything down. You're just guessing what you could plug in for x that would make this true. And you'd be surprised, sometimes your gut feelings end up working out. Now we are going to actually do the math here. The first step I take after that guessing is to identify my equal sign. And now I look for whatever variable, in this case x, that I need to solve for. I just got one little guy here. Right now it's an x plus 5 and I want to get him by himself. So I have this plus 5, don't like it, want to get rid of it. And if I manipulate this left-hand side of the equation, I got to do the same thing to the right side. So whatever we do to one side, we got to do the same to the other. And I'm going to undo this plus 5. So I see there's a plus 5, undo it, I'm going to subtract a 5. What I do to one side, I got to do to the other side. What this will do is get our x by itself. Because if we add 5 and then take away 5, they cancel out. That's really 0. If we add 0 to x, it's just x. So we don't usually write plus 0 here. We just let x hang out by itself. And now we'll go ahead and simplify the right-hand side. We got 15 minus 5. And that gets us 10. And this is our solution. Hopefully you had dreamed that up when you were guessing an answer. And the best thing that you can do if you ever doubt yourself is check your answer. Now, checks can be done mentally depending on how intense the problem was. You might want to physically actually write it off to the side of your paper and check. We're going to do that just one time here, but most of our checks we'll do mentally, okay? So I am going to plug in 10, which is our solution, into the original problem, which is x plus 5 equals 15. And I'm going to try to see if instead of x here, we replace that with 10. And I want to know, is this still equal? And we'll just simplify. 10 plus 5 is 15. And I think 15 still equals 15, so this works. So x equals 10 is our solution. There is a couple ways we can write our solution. I like x equals 10. If I'm being a little lazy, I use this curly bracket. It's a little fancy. It's saying the solution set is 10. So the solution is just 10 is how it's written. There is no 10 floating loosely on the page though. Okay, either you're writing x equals 10 or you're putting in the little curly bracket saying this is a solution. If you really love to write things out, you could say the solution is 10. You notice I didn't write that. I don't usually like writing out a bunch of words. I make mistakes when I write a lot of things. All right, so now that this problem's done, you're probably thinking, that was kind of nice. They're probably going to give me a way harder problem. They being us mean mathematicians, right? But really, we're just going to see the same problem. It's going to be displayed a little bit differently. Let's say we got something, new problem, okay, guys? We got -6 plus z equals 6. At first glance, you might freak out because you're seeing this negative sign. Don't worry, it's just us mathematicians trying to trick you. It's nothing to fear. We're going to do exactly the same thing we did before. Maybe if you want to guess, go ahead. If you're over guessing and you're like, let's just do the math, crazy lady, let's do it, okay? So my first instinct is to identify that equal sign. So I circle it and highlight it, whatever you like to do. And then I focus on the side that has the variable in which we're solving for. In this case, we got z. Z is in a different spot than how the x was previously. Don't sweat it. Just read it out loud to yourself. Whisper under your breath. No one's judging you. You got -6 plus z. Well, again, I want this z by itself. So I'm going to undo this -6 plus there. Okay? Now, some people like to try to undo the operation. Not necessarily the case because they've swapped the order on us. We want to undo this -6, okay? And the best way to get that gone is to make it be 0. So whatever I do to one side, I got to do to the other. Don't forget that. And I got -6, so I'm going to add 6. Let's check ourselves. -6 plus 6, that cancels out. That's 0. We'll just be left with z. Cool. But don't forget, what I do to one side, I gotta do to the other. And it's the same thing. So the -6 plus 6, 0, 0 plus z is still z. Sorry, I write my z's a little bit funky. They got a line through them. You'll get used to it, I promise. And then on the other side, we got a 6 plus 6, which is 12. And then you just mentally check -6 plus 12. Well, -6 plus 12 is the same thing as 12 minus 6. And sure enough, that is 6. Alrighty. So at this point, I would say give yourself a moment to try this next problem on your own. Pause your screen, try it on your own, and then resume to see if I get the same thing as you. Okay? So here's our third problem. And we have x minus 3 equals -3. So pause it, try it on your own. Now you've unpaused it, and we are going to do this together. We're going to do it a little bit faster since we've done 2 already together. We find that equal sign. I draw a line so that my brain visualizes the 2 different sides, okay? I see I got x minus 3. All right, I want to undo that. I want to get rid of this -3. So I'm going to add 3. That goes ahead and cancels out. I'm left with just that x. What I do to one side, I gotta do to the other side. And I gave you this problem to try on your own because for some reason, when students have a solution that results in 0, they panic. And it's going to happen every now and then where sometimes your solution is 0. That's okay. That's a valid solution. Sure enough, -3 plus 3 is 0, so x equals 0 is our final answer. That's with addition and subtraction, okay? Now we're going to try to add a little bit more to our fundamentals, okay? So our linear equations that we have with one variable, they deal with addition and subtraction, which our previous 3 problems have done. Now we're going to add a 4th problem. And you're going, wait, are the directions still the same? Yeah, it's still solve. We wanted the variable by itself. But now we're going to deal with some multiplication and division. So let's start off where we do that mental guess again, okay? We have here, and let me read this, 2x equals 6. We have a way of implying things in math that non-mathematicians will be like, oh, why would you do this to me? Well, when that number is next to a variable, that implies multiplication. We don't write it. It's assumed to be there. And sometimes we get really weird with our multiplication where we just assume you know that we are talking about it, okay? So whenever you see a number next to the variable, that's multiplication. And we are trying to think of something times 2 that gets us 6. And the problem maybe seems a little nicer now that I've written that multiplication and you're going 3, 3, 3 on the other side of your screen. Well, I'm going to do it the proper way where I'm going to undo the math, so to speak. I find that equal sign and I say, hey, what I do to one side, I do to the other. This is 2 times x, okay? The opposite operation would be division. And I like to write fractions for division, okay? That might scare some of you. It's going to be easier. You'll get used to it. We're going to divide by 2. And what we do to one side, we have to do exactly the same thing to the other side. So we've divided 2 on both sides. And you might be going, well, that's not 0. Different operation now, guys. So we have 2 divided by 2 is 1. Okay, so if we're looking at this, I'm going to write it. This cancels out. You're left with 1. 1 times x is just x. So we're left with the variable. That's our goal when we solve. We want just that nice variable. And then, of course, on the other side, we have 6 divided by 2. 6 halves is the same thing. That's 3. And there's our solution. Now you're probably starting to get a little more comfortable. And let's see if I can try to make you a little uncomfortable. I'm going to throw in a negative, because those are fun, right? We got negative 5x equals 10. Okay? Same story. Don't let me, the tricky mathematician, mess you up just by changing the signs. It's the same problem, okay? So when you look at this, you take your deep breath and you go, at least identify my equal sign. And go, okay, whatever I do to one side of the equation, I'm going to do exactly the same thing to the other side. So I got negative 5 times x, okay? I want to get the x by itself. Since it's multiplication, I want to undo that, and the opposite operation is division. And I'm going to divide by negative 5. Now you might be going, oh, I thought the signs or something changed. Don't get confused with addition and subtraction. They're opposites, adding and subtracting, okay? But with multiplication, it's just division. There's no sign changes here, okay? Why? Well, negative 5 divided by negative 5 is positive 1. That's our goal. We want positive 1 times x. I'm going to erase that plus sign because it's going to annoy me. But if you need to write that note to yourself, you can. We have negative 5 divided by negative 5 is positive 1, and 1 times x is still just x, which is our goal when we solve. We want the variable by itself. And you might be yelling at me and going, hey, you forgot to do the same thing to the other side. Yes, shame on me. What I do to one side, I do exactly the same thing to the other. I divide by that negative 5, and 10 divided by negative 5, okay, slow down. Positive divided by a negative is a negative. 10 divided by 5 is 2. All right, let's do one more problem, and then we're going to write down in words our steps for solving linear equations, okay? So one more. Let's squeeze it in here. I think it'll fit on our screen. Nice, sweet one. I think we're just going to have 1/5 z equals negative 10. And you might be going, oh my gosh, lady, this is a fraction. If you panic over fractions, there's going to be a separate video with all fractions so you can enjoy the fraction fun, okay? We're just going to do one in this one, though. Now, fractions are the same thing as division, okay? So you could even think of this as divide by 5. That's really what's occurring here, okay? So I'm going to rewrite this. This is 1/5 times z. That z is a whole number. If it helps you, throw it over 1. And really, you have z over 5. That's what's going on here. Let me show you that a little slower. 1 times z is z. 5 times 1 is 5. Now, it might be easier for you to see, oh, all right, so if I divide by 5, I want to undo that. That's what the name of the game is. Here's our equal sign. Whatever we do to one side, we got to do to the other. So I am going to multiply by 5. So that's the opposite of dividing by 5, the opposite operation. What I do to one side, I do to the other. If I have 5 times being divided by 5, they cancel each other out. That's 1. 1 times z is still that z. And we got negative 10 times 5, which is negative 50. Now, usually when students panic over fractions, I strongly encourage you to go ahead and check your work. Check it, plug it in, If we have 1/5 times negative 50, it's really negative 50 divided by 5. Negative divided by positive is still negative. 50 divided by 5 is 10. So we did our work right. Okay?